chapter 4 was about linear equations. Chapter 5 begins with something you should also be familiar with, except we're going to dive in a little deeper into quadratic functions. So those parabolas that we've dealt with before, that we've dealt with how to move them left and right and flip them around and stuff. So we are just going to talk about quadratic functions just a little bit more. You will see a lot of these things kind of keep building upon themselves. So let's talk about and review the characteristics of a parabola. So remember, a parabola is also called a quadratic. It is that U-shaped graph. We didn't talk a whole lot about it, but there is an axis of symmetry straight through the vertex that we could always fold a parabola around. Now, I talked about it quite a bit when I was talking about how when you are locating the vertex, if you plug in a point below it and above it of equal distance, that you should get the same value. And so that's why that happens, because of that axis of symmetry. So remember, it's a U-shaped graph. You can call it a parabola. You can call it a quadratic. The axis of symmetry cuts through the vertex of the parabola. It is the value x equals h. So if we talk about our general vertex form of our parabola, this is our vertex. Our vertex is at h and k. The a in front determines whether we flip upside down or not. The h moves it left and right. The k moves it up and down. So x equals h, it cuts through the vertex of the parabola. The x-intercept is where the actual function equals 0. So you may have to factor it. You may have to solve it a little bit. The y-intercept is where it hits the y-axis. HK, if your A value is positive and your U is opening upward, it will always be a minimum. If your A is negative, it's going to flip that U upside down, and so your vertex will be a maximum. So in calculus, sometimes we need to search for that minimum or maximum value. And so by knowing that a quadratic's minimum or maximum always occurs at the vertex is a very helpful fact to know. Okay, so parabola is a U-shaped graph, quadratic. The axis of symmetry is x equals h. The x-intercepts are where the function equals 0. You may have to factor it. The y-intercepts just plug in 0. It's where it hits the y-axis. HK will always be a maximum or minimum, and that is our vertex. When possible, this is probably your most efficient way to write a quadratic, because of the fact you can see the A, the H, and the K so very nicely. So we will talk about the fact if it's in that general form, that y equals ax squared plus bx plus c form, how to make it look like this, because that form is just so nice. Okay, I think everybody has that. So let's just talk about some more things we know about quadratics, okay? The general form, that other form, that vertex form is really important, but a lot of times you will see general form for a quadratic, ax squared plus bx plus c. We're going to explore how to take that general form and turn it into that vertex form. You can always find the x-intercepts or zeros. If it's factorable, that's a great way to go, but you can always find the x-intercepts or zeros by using a quadratic formula. That's what it's there for. So if it's in this form and you would like to know, well, where does it hit the x-axis? What are my zeros of the function? You can always use the quadratic formula. I personally always look to see, can I factor it? That's always the first thought that goes through my head. If I can't factor it, then I'm usually going to jump to the quadratic formula, okay? Remember, the vertex is always at that negative b over 2a. That is the h of our vertex, the x value of our vertex. It's used to find the axis of symmetry in the vertex. You get both kind of as a bonus. You get them both at the same exact time, which is great because as long as you know one, you can you have the axis of symmetry. You have the vertex is x. If you know the vertex is x, you can find that k. You just plug in like anything. If I want to know the y value that goes with it, you just got to plug it in. So, and then remember the last little piece there, the y-intercept, you got to plug in 0. So that would be f of 0. Yeah, so you're gonna, that's a good point, that you're just gonna make x equals 0. So you can just plug it in. You can plug it into the original function. Usually when it's in function notation, it's just the y value when you plug in 0. So it's just the y value when you plug in 0. That's why it's written sometimes as 0b. So some of those things you'll remember some from before. Again, we're just adding to the knowledge that we have about these types of functions. What you'll find is in Algebra 1, you learned a little bit of these pieces. In Algebra 2, you learned a little bit more. And then in my class, we keep adding more information to things, hopefully, that you've already talked about. So a lot of those things you already knew. It's just a matter of sometimes bringing in the function notation, sometimes bringing in a little bit more information that you didn't have before. So I like vertex form when I can. So if you want to see very clearly, where's my vertex? Where is my stretch of my quadratic? That's the way you want to go. So what we're going to talk about is if we have our equation in that general form, that ax squared plus bx plus c form, how do we get it to look like that? So that's going to be an important thing that we're going to talk about. So like if we look at this function right here, we know that our vertex is the opposite of what's inside. Remember, because how it does the opposite of what we'd expect. So our vertex, you can see, is this point right here. We are at negative 2, 4, and that the negative 3 has flipped it. Now, watch something that's kind of cool. If you look, see how it's 1 over and 3 down, 1 over and 3 down. That will happen. Remember how normally we go 1 over and 1 up. That multiple will appear at that point. Wherever the vertex is, if you go 1 over, it will go, in this case, down 3, instead of going 1 over and up 1. So that a value appears in that relationship. So that's something we're going to explore. So again, hopefully this is ringing a bell that we have kind of picked and done some of these things as we've gone through the process this semester. Remember that the x-intercepts and y-intercepts, the x-intercepts are where we hit the x-axis, the y-intercepts are where we hit the y-axis. The x-intercepts, we could have no x-intercepts because it never hits that line. You could bounce off of that just once. And what happens there is if your y value equals 0 of your vertex, or you can think about if we have a perfect square, it'll bounce off that perfectly. So that only hits it once, you'll see. Sometimes it hits it twice, and that's what we see a lot of times. This one, you'll notice, see how they're nice and pretty numbers like that. If it hits it twice, you can find these values using your quadratic formula or factoring. These will factor out really nicely. So remember, the x-intercepts You can use by factorization, so factor when possible. But if you can't factor, knowing that quadratic formula is super important. So make sure you know that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So you have to know that by heart. Please make sure you get that into your brain. Remember, the y-intercepts, you're just going to plug in an x value of 0. So again, those should be just kind of things that we know, and that we'll explore more when we get to an example. So let's look at our first example. So you'll notice that this is in our general form. So there's a few things we're going to do here. We're going to practice finding the vertex. We're going to practice getting it into that vertex form. We are going to graph it. We're going to talk about domain and range. We're going to talk about everything you could possibly talk about for this function. The first thing we're going to do is find the vertex. So the first thing we want to do is we want to find the vertex as x, which is negative b over 2a. Okay, so our a value is 1, our b value is negative 2, our c value is negative 3. Okay, so we're going to pull those values out, make sure they're in descending order, the square, then the x, then the number. And so the opposite of b, I always see, when I see negative b in my brain, I always go the opposite of b. So the opposite of negative 2 is 2. A is 1, so just double that. That is your denominator, so that's going to be 2. So our vertex happens at 1. Now, we need to find the vertex, remember, is 1 and whatever f of 1 happens to be. So we got to plug in 1. So we're just going to get 1 minus 2 minus 3, or negative 4. So our vertex is at 1, negative 4. Our vertex is at 1, negative 4. So now let's talk about vertex form. Vertex form is a times x minus h squared plus k. Well, we earlier identified our a value was 1. We found our h and k value is 1, negative 4. So we have everything we need to put it into vertex form, right? Okay, so let's look. Our a value is 1. Our h is 1. Our k is negative 4. Now, please note this one changed sign. That was a 1, but in the vertex form, it becomes a minus 1. This one stayed what it was. It was negative 4. It is negative 4. So this one should never change. This one should always change. So now let's think about everything we have. Okay, let's go on our list. We have the vertex. We have the vertex form. We do have the axis of symmetry, although I didn't really talk about it. The axis of symmetry is just what you see right here. The axis of symmetry is x equals 1. Okay. So we haven't found the zeros or the y-intercept yet. Okay. So now let's find the zeros. Well, the zeros are where x squared minus 2x minus 3 equals 0, where the function equals 0. Where is the function at a height of 0? If that's factorable, factor in. If it's not factorable, use the quadratic formula. That is a factorable quantity. That factors to be x minus 3 and x plus 1. So we have x-intercepts or zeros at positive 3 and negative 1. So let's just put those over here on the graph. We hit the x-axis at positive 3 and negative 1. Now let's put our vertex on the graph. Our vertex we found at 1, negative 4. So at 1, we're down at negative 4. And let's label it with a V. So we now have the zeros. We haven't found the y-intercept, but that's easy. We're just going to plug in 0. That's going to be 0 minus 0 minus 3. It actually always ends up being your C value when it is in general form. It's just that C value. So it's 0, negative 3. We can put that on the graph. Okay, so let's make sure we got everything. We have our vertex axis of symmetry zeros. We have our y-intercept. And then let's graph it, and then we'll talk about the domain and range. Okay, so let's put that in there. Perfect. So we've got our little parabola. Now, we did not put on our axis of symmetry, so I would like to do that now. So let's go ahead and do that. So your axis of symmetry just is the line right through. It's the line x equals 1. And it should directly hit your vertex. If it doesn't hit your vertex, you didn't get the right vertex or you didn't get the right axis of symmetry, one or the other, okay? So now we have everything on there. Let's talk about domain and range. So there's nothing that is restricted. This will eventually open up as wide as it can go from negative infinity to positive infinity. So the domain is all real numbers. The range, we talked about earlier that the vertex is always either a maximum or a minimum. This is a minimum value. It is actually an absolute minimum of our parabola. So that affects our range. If it's a minimum or a maximum, it affects our range. So our range will be -4 to infinity. Do we have any questions about that example? So that's everything we possibly could really mention about a parabola. Okay, let's do it again. Okay, so first thing you always do is find negative b over 2a when it's in this form. Okay, so our vertex is x is negative b over 2a. Now my a is going to be 2, my b is going to be -6, my c is going to be 7. So it is going to be the opposite of -6, which is +6, and 2 a's, which would be 4. And then just reduce that down as much as possible. That's going to be 3 over 2, 3 halves. Now remember, that's our axis of symmetry. X equals 3 halves, or you could call it 1.5 if you want to. And then remember, we've got to plug in 3 halves to find the vertex's y value. If you know the x, plug it in to find the y that matches it. So let me do that. So we get that the y value is 5 over 2, or 2.5. So our vertex is the point 3 halves, 5 halves. Now I like that fractional form, but if you told me 1.5, 2.5, go for it. There's nothing wrong with that. Okay. So we get the vertex. The axis of symmetry kind of is a free bonus. It is just the x value of your vertex. And now we know vertex form. It's the a value, x minus the x value of our vertex squared, plus our y value of our vertex. Okay, so we have now our vertex, our axis of symmetry, and the vertex form kind of all go together. They're all one big, lovely thing. It all kind of goes together. So next thing we have to find are the zeros. So remember, just set your function equal to 0. Unfortunately for us, there is no way to factor that, unfortunately. So when you can't factor it, we're going to use the quadratic formula. So let me do that. So we're going to do that our zeros, or our x-intercepts, are negative b plus or minus the square root of b squared minus 4 times a times c is just going to be negative 56 over 2a's, which is 4. Now here's what we need to notice, okay? That right there will end up giving me a negative 20. So that means that that is a complex number. So this is complex. So there are no zeros. Now what does that mean? Well, that means our parabola is just too high to ever hit that line. So if you get a negative right here, just stop. There's nowhere that we hit the x-axis. That tells me there's complex zeros, which means I can't hit a real number line because I'm a complex number. I'm imaginary. I got that little I there. Okay, so there's none of those. But we do have a y-intercept. If you plug in 0 to either version of our formula, you get 7. So let's put in our vertex. So our vertex is at 1.5, 2.5. I think it's kind of right in the middle of that box. We know our y-intercept is 7. So that's 1.5 to the left. So if we go 1.5 to the right and 7 up from that, or that many points up, that should be another point, just based on the fact we have an axis of symmetry right there. So let's label our vertex. Our axis of symmetry is x equals 1.5. The only thing we haven't talked about is domain and range. Domain should be easy. It's all real numbers. There's nothing that I can't plug into that function. There's nothing that I can't use. The x values will stretch forever and ever to the left, to the right. But there is a minimum value here. The range has a low point at the y value of 2.5, and then can go forever up and up and up and up from there. Okay. Now let's take a look about how we find x and y intercepts. So remember, the y-intercept, let's do that first. That's the easiest one. You just plug in 0. It's always, in this form, going to be that c value. It's always 0 plus 0 minus 2, so it's negative 2. So that's always the easy one. If everything was like that, that'd be great, but it's not. But the x-intercepts, remember, are just the zeros. The x-intercepts are just the zeros. So we're just going to set the equation equal to 0. Now, if it's a factorable quantity, which this one is, then we can factor it. So I'm going to always try to factor if it's possible. And I'm going to use a technique called slide and divide. So let's talk about how we slide and divide. We're going to take this 3, we're going to slide it over, and we're going to multiply by what's there. So I'm going to pretend like it was 3x, I'm going to pretend like it was x squared plus 5x minus 6. So I'm going to take the 3, I'm going to slide it over, I'm going to blend it with the 2 that's over there, I'm going to call it a negative 6. And I'm going to factor that. And I'm going to pretend like the other one doesn't exist. And that factors to be x plus 5. How about it is 6 and 1, which subtract, give me 5, and which multiply, there we go. So 6 and 1. And so I slid over a 3, and now at this point, you divide by 3. If it is divisible, you get to divide it. If it is not divisible, then just stick the 3 on the x. Or reduce it as much as you can. If there's still a denominator, stick that denominator on the x. So I'm going to make that 3x minus 1. So I just factored it. Okay, so let me go over that process again. It's called slide and divide. Okay. I slid the 3 over. I pretended that's what I was given. I factor it, and then whatever number I slid over at the last step, I got to divide it off. If it divides, it divides. If it doesn't divide, you stick that on Rx. Okay. Now, the reason I want it factored is because then I can split it up into 2 separate pieces by the zero product property. I'm allowed to pull it apart. And I get 2 zeros, one at -2, and here you get 3x equals 1. So we get that 1/3 again. See how we had that 1/3 right here? It will always get back to that. So we're going to do it again. First, oh, this one just says x-intercepts. So let's just set 2x squared plus 4x minus 4 equal to 0. Now, I always try to factor things if possible. They are all divisible by 2. So feel free, if there is a quantity that you can move out in front, if there is a greatest common factor, pick it up and move it, okay? And then that is not a factorable quantity. There's no way to break that up and get the 2 in the middle. There's just no way to do that. So we're going to use this version here in our quadratic formula. So your A is 1, your B is 2, your C is -2. Now, if you suck at factoring, you can always jump to the quadratic formula. It always is going to work for you, okay? So it's going to be -b plus or minus the square root of b squared. Now, I like to do -4 times A times C kind of in my head or to the side. -4 times 1 times -2 is +8 over 2 A's, which is 2. Again, let's go over what I just did. I do the opposite of B and write it down. I do B squared in my head, write it down. I do -4 times A times C in my head or to the side and write it down. And so I get -2 plus or minus the square root of 12 over 2. Now I can't do much, but the square root of 12, since 12 is 4 times 3, is 2 radical 3. So why not write it like that? So I would like you to reduce it as much as you can. Now, only if the 2 is divisible into both things, because it's under. You'll hear the formula say all over, you know, that all over. So when you do that all over portion of things, that 2 is divided into both pieces. And so our final answer would be -1 plus or minus the square root of 3. Now, if you were actually graphing this and you wanted to find where does it hit the x-axis, you would just put into your calculator -1 plus square root of 3, get a value like to the nearest tenth, and you're going to have to kind of guesstimate where that hits your x-axis, and -1 minus the square root of 3 to get your second value. They should be equidistant on both sides of your vertex, so that's kind of a way to check your work. They will always be equidistant from your vertex. The vertex is smack dab in the middle of those 2 values. Okay. So word problems happen when you're dealing with these types of things. So let's take a look at a word problem about quadratics. It says a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. Find a formula for the area of the enclosed fence if the sides of fencing perpendicular to the existing fence have length L. Okay, so let's think about the area is length times width. But let's think about how much wire she has. She has 2 L's and 1 W that she has to use 80 feet. Okay, so if she wants to just solve for W, that's W is 80 minus 2L's. So let's take and find a formula that only has L in it. Let's replace by substitution our W with 80 minus 2L. And then if we actually multiply, we get 80L minus 2L squared. Now I'm going to put that into general form by putting my L squared first. So then we can see our A and our B and so on. Okay, so we have a formula. This is an upside down parabola. So it has a maximum at the vertex. So it says find a formula for the area. That's what we did right here. And it says what dimension should she plant her garden to maximize the enclosed area? Well, maximums occur in an upside down parabola at the vertex. So they're just really saying find the vertex. So the vertex is at negative b over 2a. So the b value is 80, so opposite that's negative 80. The a value is negative 2, double that, that's negative 4, so that's 20. So that is our L value, our X values are L's, and so that is 20 feet. Now, W is 80 minus 2 L's, or 80 minus 2 times 20. 80 minus 2 times 20 is 80 minus 40, or 40. Now let's think about if it worked. Okay, we have 80 feet of fence to use. This side's 20, this side's 20. 20 plus 20 is 40. This side's 40. 20 plus 20 plus 40 is 80. We used up our 80 feet of fencing. So if they say, what are the dimensions to maximize, it happens at the vertex when L is 20 and W is 40. So we would say we want to make it a 20 by 40 pen. Now, what is the area that we are maximizing? Well, it's just 20 times 40, or it would be 800 square feet. Now, they didn't ask that, but it's important to know how do they ask the question. Sometimes they'll say, what's the area that you get? What's the biggest area that you could ever enclose with that fencing? And you would say the answer is 800. If they said, what are the dimensions? It would be 20 and 40. So that's a little application there. You see that type of application quite a bit in a calculus class. They don't use necessarily the algebra we did. There's some things called derivatives they use, but they get the same answers. Okay. Last one. So a lot of times you will see that these functions are used when it comes to modeling something that has moved in an arc. So a lot of times it could be, you know, if you throw a football, think about the arc that a football makes. Even just your motion, if you even drop something off because of the way that physics work, you get parabolas quite a bit. Okay, so we have this ball thrown upward off of the top of a 40-foot building at 80 feet per second. So you see how here we get the 40 and the 80, and this has to do with the speed, how the acceleration of gravity. Anyway, when does the ball reach a maximum height? Well, it's an upside down parabola. Where does the maximum occur? It occurs at the vertex. So we get to do negative b over 2a. Now it says when. The word when tells us we're looking for time. So we'll call it t like they did. Okay. So we're going to do negative b over 2a very quickly. We can do that. That's going to be negative 80 over negative 32. Now 80 divided by 32 is 2.5. So at 2.5 seconds, we are going to be at the top, the peak of our parabola, the peak of our ball throwing that ball up in the air. Okay. It says, what is the maximum height? So that's where we would want to use the H formula. So we have to find, well, what height did we hit at 2.5 seconds? So if we plug 2.5 seconds, yes, 2.5 seconds. So if we plug 2.5 seconds into our equation, we get 140 feet. Now, C is different. Let's just, okay, I can't draw, but you'll get an idea, okay? So that's 40 feet. We threw the ball up. This was at 2.5 seconds. It's at 140 feet. And the question is when does it hit the ground? Well, in that case, you can think of this like the x-axis. So we're really looking, when are we going to hit the x-axis? When are we going to be at a height of 0? So for C, all you have to do is set your equation equal to 0. Now, to make it a little nicer, I am going to divide everything through by 8. Actually, let's take out a negative 8. So I get 2t squared minus 10t minus 5. Make sure I did that right. 2, negative 10, negative 5. Now that is not a factorable quantity, unfortunately, but we can use the quadratic formula on this thing right here. So it's going to be negative b plus or minus the square root of b squared minus 4 times a times c is 40 over 2a's is 4. Now, one of the numbers is negative, and that is over here. Does the ball ever get over there? No, it's going to represent a negative time. So over here isn't the number we want. So the -1 isn't going to work. So it would be the plus answer. So the answer would be 10 plus the square root of 140 over 4. Let me tell you when it hits the ground. So it hits the ground at, oh, that was a T. They used T, so let me put a T on there. At 5.5 seconds. So there's lots of things that occur in physics that are parabolic. They act like quadratics. So there's just lots of things that occur that follow that parabola. So just remember, vertex, vertex, vertex. Negative b over 2a is your friend. It helps you. It gives you so much information. Okay, it gives you so much information. And then there's some that need graphed, some that just ask about what's happening to the parabola, and then there are some word problems. So that is definitely something that you are going to have to dedicate some time to. And all this week, unfortunately, we're going to be doing notes up to Thursday. It's going to be one of those weeks. We got a lot of stuff we got to cover. So there you go.